All right, next on the agenda, we're going to address the topic of commercial drones, hype versus reality. Could I invite my panel members up? Also want to take time to mention that on your tables you're going to find note cards, and that is how we will address questions for the panels today. So be aware of that and prepare your questions. Welcome, guys. I'd like to welcome Dan Bartz, an associate with Booz Allen Hamilton. Dan received his Bachelor's of Science in Mechanical and Electrical Engineering from Kettering University in 2002 and a master's degree in robotics from Carnegie Mellon. He participated in the 2005 DARPA Grand Challenge and the 2000 DARPA Urban Challenge that he worked on various dynamic problems and planning problems. Dan Bartz has also worked in the area of automotive active safety and vehicle sensor technology at both General Motors Research Labs and Ford Motor. Welcome, Dan Bartz. Also, we have a representative from a company that has started right here in Ann Arbor and has a number of U of M graduates. Tom, would you tell us a little bit about yourself?
Sure. Good morning, everybody. My name is Tom Brady. Can you guys hear me? You guys hear me? Now, can you hear me?
You want?
Check, check. I'm supposed to know about robotics. I can't even turn on a microphone. So good morning, everybody. My name is Tom Brady. I'm here from SkySpecs, LLC. We are a startup company in Ann Arbor that makes drones that inspect things like wind turbines, sewers, bridges, you name it. I graduated from the University of Michigan with my bachelor's in 2011, went on a year and a half to eventually complete my master's, both in aerospace engineering. My college experience was more or less defined by Michigan Autonomous Aerial Vehicles. Their booth is over there. You should make sure to stop by. That's my shameless plug for those guys, but that's all for now.
All right, so first questions first. When can I expect my pizza to be delivered via drone?
I won't be delivering your pizza, your beer, or your flowers by drone. But if you ask Amazon, they're saying 5 years from now. I don't know if I believe it yet. There's a lot of things that have to be overcome. Amazon, for example, doesn't currently have a way to avoid the children that are playing in the front yard with the drone that's delivering their packages, or Pizza Hut delivering your pizza. So I think we still have a long way to go, at least 2017.
There have been a number of initiatives to try to do, I think, tacos by drone, and I think there was a beer drone to deliver beer to ice fishermen out fishing on a lake, and the FAA has stepped in and said, no, we don't want you doing that. So I think a lot of things are going to depend upon the FAA is currently in the process of trying to work out what does it take to do commercial drones, and what are the safety implications, and a lot of the commercial application of drones is going to be dictated more by regulatory affairs than necessarily by the technology.
Now, we have a lot of students at various levels in the audience, and we have researchers, we have people in industry. Could you guys address briefly your origin story? What got you interested in this technology, and how did you come to be here?
Sure, I'll start that off. So as I mentioned, at the University of Michigan, I was part of a student group called Michigan Autonomous Aerial Vehicles. The group actually came out of a senior design project at Michigan. So if you're a senior at Michigan in the aerospace program, you can either choose from a set of sponsored projects by the industry, or you can choose to create your own project. And that's what me and several of my colleagues, when we started MAV for short, that's what we did. Why did we get interested in doing such a thing? We wanted something that was going to be very hands-on. Phil talked earlier about how making things is the closest we can get to magic. Engineering is the closest we get to magic. I really like that. So that's what we wanted to do. It's really hard in a senior design project to make a 737 or anything else that's aerospace related. Whereas if you're making drones that are only 2 feet across, that's something you can definitely do over the course of a year. So that's what we did.
So I've always been interested in robotics since I was a kid. Maybe it was watching Transformers and Robotech. You know, as I went to Kettering University, which is a university that really focuses on undergraduate co-op, and I started working at ABB Robotics in manufacturing, and I was really fascinated with the ability to take a manufacturing robot, which typically was repeat the same process over and over again, and how do I start giving it intelligence, giving it the ability to adapt to changing situations, giving it the ability to change without a human having to come in and reprogram it. And I later got a chance to go to work with the GM Research Labs also as a co-op student, working on collision avoidance and brake-by-wire systems and safety systems, and I started to see how robotics and drive-by-wire and collision avoidance would come together. I got a chance to go to Carnegie Mellon to get my master's in robotics. I decided that's where I wanted to go. My coworkers at GM said, well, robots, you don't want to work in manufacturing, do you? I said, no, this is about the car being the robot. I worked on the DARPA Grand Challenge for the 2005 Grand Challenge. We had our vehicles finish second and third place. There were 2 autonomous Humvees. I later went on to work on the Urban Challenge with autonomous 16-ton military MTVR truck. And you know, when we were working on this, no one was talking about autonomous cars on the road. And as things like this started to roll out, all of a sudden this went from being a cool, almost hobby to this is kind of becoming a mainstream an industry. And it's just a really exciting opportunity because robotics stresses so many different engineering disciplines. That you really have to be able to wear a lot of different hats as a roboticist, whether it's mechanical, electrical, software, policy, you know, and I think it's a pretty exciting field to be in.
And Dan, just to be clear, you're doing that work here in Michigan?
Yes, right now I'm working at, for Booz Allen Hamilton, I'm working at the United States Army TARDAC, which is in Warren, Michigan, on automated trucks. So we're trying to take soldiers out of harm's way by having the trucks used in military convoys be able to drive themselves and other types of automated logistics.
So when we're talking about drones, okay, there's a difference between the little toy drones and the kind of vehicles we're talking about. Could you address what those differences would be?
So you know, there's a lot of these kind of homebrew drones. I think Chris Anderson, who used to be editor of Wired Magazine, did a really big service to the drone community in starting a do-it-yourself drone website, which really got a lot of enthusiasm around these quadcopters and other low-cost technology. Other drones are basically RC airplanes. That differs a lot from the types of drones that we use in the Army. Anything from small drones that you can pick up and throw to Predators, to even the Global Hawk, which is got a wingspan 5 feet longer than a 757's wingspan. As you get into those larger drone systems, the bigger things is the aircraft is so large that you now have to apply the same types of engineering principles and standards that the FAA requires for commercial. And in fact, I believe the Global Hawk currently is the only military aircraft approved for flight within U.S. airspace, and it does so by filing its own flight plan with the FAA autonomously. And so, there's a lot difference in terms of both how these things are built, but as well as the levels of engineering rigor and documentation that you need to be able to go to whoever the governing agency, and in many cases the FAA, and say, this is a safe system, and I can prove it with the engineering that I have behind it.
Yeah, to add to that a little bit, to do our sort of competitive research, we have several of these off-the-shelf type toy drones. The one you can get at Brookstone, it's called the Parrot. The DJI Phantom is another one that we've experimented with. And even we as people that fly these things around all the time, the very first thing one of my partners did when he got one of these things flying in that was crash right into it. These are the kind of things that aren't acceptable for an industrial grade drone where if, say, I'm flying around a wind turbine, for example, and I've got a pilot that's an inspector, he's not a trained remote control pilot that can reject wind disturbances that are 50 miles an hour and upwards. So the level of autonomy, the sophistication in sensing, very far beyond what is available at the sort of toy level. And we actually find it makes a big difference. The customers in the toy arena or the people that want to do remote control acrobatics, they just want the experience to be fun, right? Like if I'm flying around a drone, I want to be able to do whatever I want with it if I'm just using it as a toy. Whereas in these industrial applications, what they care about is data, and that's sort of what we're trying to deliver.
Now, what kind of regulatory concerns are in place? Recently there was a move to set up areas where these drones could be tested. And what was your experience with that? Because I know that you guys need to do a lot of testing. If you want to inspect wind turbines, you need to do testing preferably close to where you are. So what's been your experience with that?
Yeah, so it definitely has been a challenge. That is sort of the elephant in the room when it comes to SkySpecs is, what do we do about regulatory policies? Right now we actually have 2 guys in Washington, D.C. that are pitching at the White House the things that are kind of holding back our business as far as the FAA and whatnot. Just to give you a background on what's going on with the FAA, in 2013 they announced their 6 UAV test sites. And these test sites are going to be locations where unmanned aerial vehicles, drones, whatever you'd like to call them, can apply to the operator of the test site to actually fly their vehicle to conduct testing, and for the first time ever, actually charge a customer for that service. So up until now, commercial activity of drones, it just not even on the radar for most of these companies.
No beer drones?
No beer drones. As far as I know, there's no beer drones in the FAA test sites at the moment. The test sites are supposed to be online in June. So we are looking to do our first our initial commercial testing at a wind farm, likely in Texas, with one of our partners.
Dan, what's the difference between when you do a testing of a military vehicle versus a civilian vehicle? Is it easier to test military vehicles because you have access to facilities, or is it that the same regulations or regulatory things don't apply?
In terms of the testing, the Army has its testing procedures. There's safety standards like MIL Standard 882E, and we have testing facilities like Aberdeen, and I don't know all the air testing facilities. The testing is different. One of the things you typically don't have in military testing is the ability to get as many miles as a General Motors or a Ford might for ground vehicles, or Boeing for air vehicles. But we do have a lot more harsher tests that have to be gone through. But in terms of the standards, yes, there are differences between a military software safety standard and a civilian software safety standard. But when you go through them, they're actually very, very similar in terms of the levels of reliability and the types of things you have to do. The environments are different. But I think there's a lot of synergies, and what you're recently starting to see is more and more military aircraft, including drones, are now being asked to meet the civilian standards that the FAA has laid out, just as kind of that extra, confidence check that these air systems are extremely safe and is almost never fail.
Tom, you talked about that you guys have done competitive testing with the drones that you can buy off the shelf. What goes into creating your drones for your application? What are the different skills that you guys have had to put together?
As far as the different skill sets on the team?
Yep.
Yeah, so that is one of the coolest parts about robotics, and being a robotics community, I'm sure you guys know how multidisciplinary this can be. Everything from the mechanical engineers that design the system and build the molds that we make. We have a carbon fiber airframe, all the way up to the circuit boards that we design in-house and then ship out. That's an electrical engineer. Then you move on a little bit further. What software do you actually put on those circuit boards to make it so that the vehicle stays aloft? Those are controls engineers from the aerospace program. And then you go one step above that, then you've got, how do I actually make the vehicle go where I want it to go in space? And those are our software engineers, our roboticists, and our artificial intelligence type folks. So SkySpecs has 9 people on the team, and we are representing 4 different engineering disciplines. So very exciting project to work on. Actually just yesterday we had something, it was a catastrophic fall from the sky, at least in our netted area. But in a matter of 15 minutes, we had our systems integration and our mechanical guys have it right back up and running for a demo for some investors that we had yesterday afternoon. So that's part of the fun in all this, is like when something breaks or when something needs to get done, we've got the people to do it.
Dan, why do you think there's so much military testing and Michigan is a center for a lot of this autonomous vehicle testing that you're involved with and autonomous vehicle planning?
At least speaking from the ground vehicle space, historically Michigan has been very much involved with the development of military ground vehicles, particularly from the Arsenal Democracy days. The TARDEC, the Tank Automotive Research Development Engineering Center, and Tank Command, the Tank Automotive Command, are both headquartered in Warren, Michigan. And so that's where the Army does its ground vehicle activities. The fact that we're so close to the auto industry allows us to really take advantage of a lot of the sensors that are being developed and the other types of components that are shared between military systems and commercial systems. And so both the historical nature of how much Michigan played a part of World War II, plus the really strong presence you have here in the automotive community, including the companies that are making a lot of the types of sensors we use, the radars and the cameras, really puts a lot of strength in terms of trying to develop these types of systems in Michigan.
Tom, I know that a good chunk of your team is at the White House today, which, by the way, is exceptionally cool that a startup here in Michigan is being consulted on how regulatory things can be changed to help them grow. But, you're a cool startup.
Very cool.
You're IT related. Why are you here? Why? I mean, shouldn't you be out in California somewhere?
Shouldn't we be? We actually, when we first started the company, we did evaluate whether or not we needed to move to Silicon Valley, whether or not the resources would be here in Michigan, and the answer was a resounding no. We do not need to be in Silicon Valley to make this happen. Michigan has everything we need. Earlier, what Rick was talking about, the combination of infrastructure, investing, and talent was the third one? Help me out.
The talent part.
Oh, right. So talent was the third one. University, there's several top-notch schools in the state of Michigan, but the one that we're from is the University of Michigan. So we've centered ourselves, where we've located ourselves in Ann Arbor, right where we can pull top-notch talent out of programs. Looking at infrastructure, look at Michigan manufacturing. We, of course, don't have volume operations at the moment, but when we do, I guarantee there's somebody in the state of Michigan that is going to be able to support that. And then number 3, the investing. SkySpecs has already done a seed round for $500,000, and we raised it. It was a struggle for any startup to raise money, but the fact that we were able to do that right here in the state of Michigan, I think, would surprise a lot of people in some other states that are not exactly looking to Michigan for strength in its investment community.
All right, gentlemen, thank you very much. Please, a hand of applause for our panel.